So this question involves functions and their inverses. So let's have a look at what the function f does. For instance, if we start with a, f will send a to 3 times that plus 5. Whatever goes into f, out comes 3 times that number plus 5. And we'll call that number b. So when we're looking for the inverse of f, we have to this time start with b and find out what we do to b to get back to a. So let's write this down. So at this stage, we now really need to work something on b to get a on its own. That's what this is all about. What on earth does f to the minus 1 do to b to get the result a? So let's solve this equation for a. Change the subject to a. So we've got b minus 5, take 5 from both sides, and let's then divide both sides by 3. So we've got b minus 5 divided by 3. A third of whatever b minus 5 is. So to get back to a, we have to subtract 5 and divide by 3. Another way of thinking about to get a. Another way of thinking about that is that f, remember, it multiplied by 3 and then added 5 in that order. So undoing them in the correct order would be taking away 5 and then dividing by 3, which is what we're doing here. So f to the minus 1, what does it do to b to get a? It subtracts 5 and divides 3. So therefore, what would it do to x? It would take away 5 and divide by 3. Normal descriptions of functions involve x. Up here, f was described by what it does to x. It gets 3x plus 5. So what does f to the minus 1 do? The inverse of f do to x? It takes away 5 and divides by 3. So that's the formula for f to the minus 1 of x, inverse of f. So that's part A. Let's have a look at part B. We're told that if we start with the number 2 and then act with g, so 2 goes into g, 7 comes out. And we're asked about the inverse. What does g to the minus 1, the inverse of g, do to 7? Well, because it's the inverse, it gets back to 2. So since when we put 2 into g we get 7, 2 maps to 7, then the inverse, when we put 7 into g to the minus 1, we'll get back to 2.